Welcome everyone. Welcome back from lunch. Hope you had a good lunch. I did. I'm Leon. Some of you know me, some of you don't. Do a bunch of things, among others, a lot of core hacking and a lot of XS modules. And I'm here to talk about XS because um, a lot of people think XS is very difficult, and I think it is not nearly as difficult as people think it is. I just think that our documentation is making it difficult. So yeah, let's start with what is XS. XS is a preprocessor. It allows you to write a small amount of code to glue Perl code and C code, and it will generate C codes, behind the C code that's involved in, binding the two. You could also write the C code by hand, but that actually would be a lot more difficult than, just writing a small amount of XS. When people say XS is difficult, I also think a large part of that is actually not XS. It's the Perl API. It's the C side of the Perl implementation. And the Perl API is, above all, very big. It has, I should have looked up exactly how much, but basically thousands of functions. Literally thousands of them, which makes it very hard to, like, where do you get started? But on the bright side, for a lot of purposes, you only need a fairly small subset of it. The other thing about it is the Perl API has a very specific dialect of C, and this is especially it's using an enormous amount of macros. Again, thousands and thousands of them, which makes it a bit surprising even for someone who otherwise knows C. Okay, some history. How did we get there? Well, actually, for that we have to go 30 years this year. 40 years. Not 30. You have to go back 30 years. Because Perl 5 was released in 1994, and that was the first version of Perl that had extensions. Because in Perl 4 times, a few of you may remember that, it didn't have extensions. This is one of the reasons why Perl has a lot of built-in functionalities, like around Unix APIs like shared memory and semaphores and all those things that don't really belong. They don't really belong like in the core language, but everything was integrated because you couldn't do it another way. There were no extensions. If we would do that again now, we would have made that an extension. And this started to truly break when people started using databases. Because what people did back then was basically they had a bunch of variants, a bunch of patches for Perl to integrate like Oracle or Sybase or whatever into your Perl, and have like a bunch of additional built-in functions to be able to access that database. And obviously, this does not scale. This means you need a very specific Perl for like this database. And this was a mess. This was not a good solution. And this was really the problem that forced them to take a new look at it and make something that's extensible so that you can have one Perl and you can support any database or anything else. And this is, of course, what became DBI. This was very much developed a lot. DBI was in a lot of ways developed even before Perl 5 was done. They were developed alongside, and this was a very big influence on XS. Because DBI and the DBDs are both heavy users of XS. Not all DBDs are in XS, but most of them. So yeah, in practice, in my experience, there are 3 different kinds of XS modules. And they have very different needs and difficulties. The first and most obvious kinds are library wrappers. And I would expect that this is the vast majority of XS out there. If you think of, like I need to use some XS for something, you're probably thinking of there's this library that I have to, I don't know, parse XML or whatever, and I want to use it, and and then you integrate that into Perl. Um, and one of the typical things about this kind of module is that actually you don't actually need you usually don't need the Perl API that much for this. It's more, this is heavy on the XS side, but not that heavy on the Perl API. Not necessarily heavy on the Perl API. It can be. The second category is when you're extending the language, which is the sort of thing that Paul was talking about this morning, which is actually the exact opposite. If you look at like the modules he's talking about, there's actually very little XS in there. It's almost all C, which again is a very different kind of module, which is also like has a very different kind of difficulty, because this really requires you to know a lot of these modules require you to know so much guts of Perl that you kind of need to be like, you need to be on the P5P list to do any of this. And the third category are like modules that try to speed up something that could have also been done in Perl. And again, DBI is not a well-known example of this, but also text CSV XS. Is also like, and this is a bit, this category tends to be a bit in between these two. You kind of need both. But like I said, in my experience, what most people need, what most people need when they say I need to use XS is they need to write a library wrapper, which don't look that way. You're not most people. So yeah, that is what I'm focusing on here in this presentation. So yes, so what does an XS file look like? It has different sections. It starts out with a section for all the C code, and then you have one or more sections of XS. And the C code generally starts with these 3 lines of boilerplate. This is really just importing all the things that you need to extend, to write an extension for Perl. And then, in the C section, you can have, you can define whatever function you want that does whatever you need. If you're writing a wrapper, you don't need this section that much, usually. But sometimes you do for like mainly conversion kind of things. If you often see code using the no get context feature. I should mention that you can ignore this entirely if you want to, but your code will be slower, especially on threaded Perls. There is a bit of a theme where, well, actually, Perl has a feature called multiplicity, which basically means you can have more than one Perl inside a process. The most common reason to use this is threads. It's actually not the only reason. For like embeddings, so it's also for embedding, it's sometimes also used. And so this means that your C code needs to know which interpreter it needs to work on. And therefore, it's using some 1800 macros to try to hide this all from you. This is a pattern. The Perl API is an explosion of macros. But if you use this option, you need to explicitly use the PTHX and ATHX macros, explicitly pass it instead of it fetching it every time. You can ignore these 2 slides entirely if you want to. But like I said, if you care about speed, it is a good idea. If you get started, you start out ignoring this, and then at a later stage you can get back to this. And oh, this thing is very fragile. Okay. The other thing you should know about regarding the C section is PP ports. PP port is basically a backwards compatibility utility. It's written in the most fascinating way. That's the correct response. There's a script in core that generates this module. And then when you use this module, it generates the file ppport.h. And then you might think this is a C header. And that is only half of the truth, because it's also a Perl script at the same time. That if you run it will help you, it will generate the patch for you to add PP ports to your XS module. Yeah, so this is generate something that generates something that generates something. I don't know who made this up. I would have done this differently. But yeah, you can use, there's this, just you use one-liner to write the file, and then you don't really have to think about it much more. And like I said, it can generate a patch for some, it looks at very specific things. But to be honest, 95% of the time you just say include PP ports, and then I didn't properly explain what it does, did I? It's basically what it does is it defines a lot of functionality for that is not available on older versions of the Perl API. It will define wrappers, so you can use newer APIs on older Perls, and it does actually a really good job if anywhere where it's possible to write your code in such a way that it will work on a very large range of Perl versions. In a lot of ways, it's actually easier to write XS code that works on older Perls than to write Perl code that works on older Perls, ironically. Okay. And then we get to the XS section, where the real meat of the XS file. The XS section starts with the module line, where you declare this is module whatever, and this is package whatever. You have to specify both, because you can have multiple XS sections and they would have the same module, but a different package. So then you would export functions that way to different packages. But 90% of the time you're just dealing with a module and a package that are the same. Yeah, oh yeah, the spicy parts. And then in the documentation, you see a lot of examples like this. It's very much written in a very KNRC style of way, where you say these are the arguments and these are the types of arguments, and then a code block and then an output block. And when I say the documentation is making this hard, I mean this is way more code than it needs to be for just export this function to Perl. And it actually can do it in a much simpler way. This does the same. For the most part, you can have an XS file that's just declarations of C functions, and it will map those one-on-one. This is probably the most important slide of my presentation, because no one, this is very much lacking in the official documentation. XS doesn't have to be that hard in most cases. It's only hard. It should only be hard when you're actually doing hard things. And almost all of the examples use code blocks to overwrite how things are mapped. And this is a very useful feature, but it tends to require a bit more knowledge of the Perl API. And in a lot of cases, it's not really necessary. Like if I look at my code, then I primarily use it to make an interface prettier. Like if I want to make an interface more Perlish, then it's very useful. But you don't necessarily have to, and you can make it easier for yourself by just not doing that, or by just writing wrappers in Perl codes that make it give it a prettier interface and have a backend that has a very C-like interface. So you can make this easy on yourself, especially when you're just getting started. Yes, there are several tricks for like avoiding having to write a C block in your XS function. And one of my favorite features there that is not used nearly often enough is the prefix. What does it do? Because like in C, you don't have namespaces. In Perl, we use packages as namespaces. In C, there's only one global namespace. Therefore, most libraries will use some sort of prefix for like all of their functions. So by saying like all functions in this package have this prefix, it will actually export this foobar baz function as the function baz in the package foobar. So then you don't have to manually do that translation in a code block. So this way again, you can this helps with really just making it a list of function declarations. Another useful feature here is cargs, which allows you to reorder the arguments or skip them. You can basically just which arguments are you actually passing, because sometimes, for example, in Perl, the object will always be the first argument, but in some C APIs, the thing that is logically the object is actually at the end. And using this feature, you can reorder them, so you can map that more directly. And the other very important feature, if you want to write XS in this style, is type maps. Type maps are the sort of feature that are an absolutely great idea with an absolutely terrible implementation, which I will show you about. But what they really do is they allow you to declare like this type in C is maps to XS and Perl to that type. And this is generally this is a template-based system, so this makes the templates very reusable, because in practice, almost everything is following a small set of patterns. So a type map has 3 sections. It has a declaration, this type in C maps to this XS type, and then you have templates for this XS type uses this uses this template for the inputs and that template for the outputs. For example, you can say an int uses the template TIV. This is one of the core examples that is in the default type map, and then for the input you can declare TIV is, well, I think it uses this template to replace the right type and argument and variable and everything. And now you might think this looks rather Perlish. This looks deceptively Perlish, and it is, because the implementation of this put double quotes around it and a valid. Great. That's why you can't put quotes in type maps. It will like break into, you get really confusing errors. And the simplest thing that could possibly work. Like I said, the implementation is kind of terrible, but the idea is brilliant, because type maps are a really good way to reuse these kind of conversions. Most of the time, you should not need to write your own type maps, or maybe modify an existing one slightly, but you mostly want to avoid it. But if you write it, you want to be using them all the time. And again, output type maps are very much the same. It's just a piece of code, a bunch of variables, except you can use double quotes here, unlike the input type maps, because logic. But yeah. Now you think this looks another very good way to cheat with it is, and like reuse it, is use the packed templates, because this will just allow you to, you say your type uses a pack template, and then it will call these two functions for like the input and the output. So this means that you don't actually have to write your own templates. You can just write, these 1 or 2 C functions that have the right name, and it will all automatically use that function. And then you don't have to write templates, and that is good because writing templates is terrible. And finally, one of the most important templates that I really should talk about is pointer objects. This is the most common way to implement objects in XS code. And typically here I see again, like I'm mapping the probe type foo bar to a pointer object. And then I don't have to write any further template for this. And then like everywhere in my XS code, I just use the type foo bar for like arguments and for return values, and it will pick the right template. It will write all the code involved in converting them. The only other thing that you have to do, and this is a bit unfortunate, is that you have to write a type def for your type, because C doesn't allow colons in names, so you have to replace it with underscores. This is a limitation of C, unfortunately. But mostly, if you write these 2 lines, one in the type map and one type def, then this will automatically work. You don't have to write any C code or XS code otherwise to make objects work. Except, of course, it's not this simple. Because it turns out pointer objects serialize in the worst way. If you put this in storable and then load it back later, then that pointer is pointing to garbage, and your program is probably going to segfault. You should probably not put XS objects through storable anyway, but people do. Also, this doesn't handle thread cloning very well. Like I said before, threads make things more difficult in XS. Some people solve that by just not caring about threads. It's yes, I was looking at you for a reason. But there are solutions for this, because there are other templates to do this. They're just not in core. And that's where template bundles come into play. Because the system there are like template bundles on CPAN, again, that you can reuse to make all of this more easy. When I say there are bundles, I really mean there are 2 people who've written bundles, and I'm one of them. So yeah, basically I wrote this tool for you. Then basically, if you need to use a bundle, you can just run this command once, and it will write the latest version of that bundle to your type map file, and then it automatically works. Or with DZIL, you can do the same. One of my type maps that I think is very useful is opaque objects. And actually, this one is how it works is very easy to explain, because it's just putting a struct into a string. That's really all there is to it. Which means it's a very good option if you have a struct that doesn't contain any pointers or file handles or like any external reference like that. This is a perfect solution, because it's easy. You don't have to think about anything otherwise, and it will serialize sensibly, which is a useful trait. How do you know if you can, if your struct is suitable for this? It's actually very easy to tell, because if you need to use any sort of destruct function with it, you can't use it. That means it's doing something funky and you should not be doing this. And the other option, of course, is magic. I think Paul mentioned it before. This is a template where this works almost the same as pointer objects, except I'm storing the pointer in magic, so it's hidden, so it doesn't serialize, so it can actually detect you've been naughty, I'm not going to go further. Um, but of course, like I said, there is still the threading problem. If you actually need threading, if you need your object to support threading, then I still have you covered. There's the Magic X template, which allows you to define a magic virtual table, which conveniently someone else here already showed before today, I think. Oh, I think 3 was in there. For example, I have a few modules where I use these 2 functions to do reference counting on a C object, like so that it will only be destroyed when it has been destroyed in all threads. I can't make it easier than this, unfortunately. I mean, it's still, but at this point, that's not really accessible. So it's really just C and the Perl API and threads being difficult. All right, I think I'm going very fast through my slides. Some other features I wanted to touch upon. There's an important XS feature called the boot block, which is really just a bunch of C code that is run when your module is loaded. This is useful for a variety of things. I personally mainly use it to define constants in my module. But there are other uses, especially if you go more into extending the language, then you're probably doing most of your work in the boot section. And there's also PP code, because like I said, these templates are really good at converting one value to another value. But the one thing they absolutely don't do is allowing you to return multiple values. So if you write anything that needs to support that is returning a list instead of a scalar, then you need to use PP code and you need to take control over the stack to decide what you want to return. Fortunately, this is actually not very difficult because, well, you need a little more. The amount of Perl API you need is actually very small because it's just a bunch of push functions. In this case, I'm using push integer. There's also push p. There's also a function for strings and for scalar value and everything. But using this, yeah, you have control over the return stack, and that way you have more flexibility if you need it. That's all. I've gone through 50 slides in any questions?
If the documentation is the problem, are we fixing the documentation? Is there a drive to do that?
If the documentation is the problem, are we fixing documentation? Yes, we should. There's some work on that. I think a lot of that, in my opinion, there's like the reference documentation that's documenting all the features, and that is okay. But then there's the tutorial, and in my personal opinion, that should just be rewritten from scratch, because it's not because it's wrong, but it's not actually it doesn't do a very good job, in my opinion, of getting you started like the lazy easy way first, and then first do the easy things and then expand on that and go in more into details.
Well volunteered, Leon.
I hate you. I think he is next.
Did you say there are 1800 C macros?
Yes, that's only for the. You asked, did you say 1800 C macros? Yes, that is only for the hiding the whole multi-threaded thing or the multiplicity thing. There are way more macros than that. Yes, and they stack. Yes.
They reproduce.
Hmm?
They reproduce even alone, or
Kind of, yes.
oh my god.
They're good.
I've written most of my XS by using inline C and then taking its XS file to modify further. What is your opinion on that approach?
He said he was mainly using XS by using inline first, taking that XS and continuing from that. It's an interesting approach. I mean, I don't really like inline for operational reasons, like how it deploys. But yes, I can imagine that working, like using that as a starting point and then developing further from that. Because the XS that it writes is fine. It's just that I don't like the part where it's like compiling in at the wrong time, and that is what I would object to. Yeah, that can work. I'm not sure it's the best you can write, but it's very functional.
I've to integrate some libraries. I've actually found it easier to use FFI Platypus. Just curious in your take on that. It just
yeah. He said he was integrating some libraries and has good experience with FFI Platypus.
good experience means it worked well. Don't ask me questions how to use it.
Well, like I said, in that slide that I said was the most important slide. You can make XS just as simple as using the FFI. I tend to prefer XS because it FFIs generally they're very good at like exposing functions. Often like constants are not exposed, and like definitely macros are not exposed. FFIs work really well if the library that you're wrapping is really clean, which is like, if you would need to wrap something that is anything like the Perl API, then you can't do that. You just can't with an FFI. So in that sense, they are limited in what sort of APIs they can support, but also, like I said, in most cases, the XS can be just as simple. Just like you can just make it like you need like to include your headers, no C code, and then just a list of declarations for the C functions, and that will work. That is enough. So I don't think I think you can write XS in a lot of cases. That is just as simple as using an FFI. While at the same time, it scales up better to like the hard cases that don't work in an FFI. That is my experience, at least. Mm. The Tux commented, he said FFIs are very hard if the function if a function argument involves a callback. And yes, there are lots of more complicated things where you really need to have some code that's wrapping things. And if you're using an FFI, what I have seen people do is essentially write some additional C code to wrap the things that are not accessible using the FFI, to make them accessible. And at that point, you might as well be using XS. Because in both cases, you're writing C code.